In this video, I am going to explain very important experiment, and it is determination of boiling point. So first, I am going to explain what is boiling point. So children, boiling point is the temperature where the vapor pressure of a liquid becomes equal to atmospheric pressure. I am writing boiling point is defined as the temperature at which vapor pressure of a liquid I will explain. Liquid becomes equal to the atmospheric pressure. It becomes equal to atmospheric pressure. Why I am saying? Because this is the scientific definition. You all must be knowing, when we boil a liquid, what happens? Suppose milk. What happens? Milk comes out. And if you have closed the vessel, then it boils very quickly. Why it is so? Because when we close any liquid which is boiling or which is being cooked, then what happens? Initially there is the formation of vapors. Vapors go up, and as we have closed by a lid, then the vapors, they are confined inside. And you might have seen when milk boils, then when the lid comes away along with the milk. And another point, in pressure cooker, the food materials are cooked very fast, very easily. Why? Because in pressure cooker there is a lid which is perfectly closed with rubber gasket. So this is the reason. So this is the authentic definition and scientific definition you have to keep in mind. In other words, you also say that the temperature at which liquid boils. So this is for kids. The temperature at which liquid boils, it is for kids, but this is the scientific definition in terms of the chemistry, and this is the only acceptable definition. And what is the vapor pressure? See, here I am drawing a beaker. Here it has some liquid, and when it is being boiled, what happens? When it is being boiled, this is the gas burner. Then what happens? The vapors are produced. Vapors go away. And atmospheric pressure, here is the atmospheric pressure. So when the two forces, so atmospheric pressure acts down, this. So when the two forces, when it starts or when they are equal, then liquid starts boiling. So this is very simple concept. Now we'll see the experimental setup, how to determine the boiling point of a liquid. The determination of boiling point, again here we take a beaker, and this beaker, it is placed on a tripod stand. Here there is gas burner. The flames are coming, and here is the liquid, and it is placed on wire gauge. This is, wire gauge. Wire gauge, it is just wire mesh. I will show you sometime. This is beaker. This is the liquid. This is tripod stand. This is burner. Now on this side we put stand here. This is the stand, a stand. This is the stand. And here we have, this is the clamp. And here we suspend the thermometer. We suspend the thermometer thermometer is suspended here. Just draw carefully, and here is the slightly more. This is the thermometer. This is the bulb of thermometer. We tie. This is the thread. This is the thermometer. This is the bulb of thermometer. This is the bulb of thermometer. So this is there. When we start heating, what happens? Liquid will gain temperature, liquid will gain heat, and its temperature will rise in temperature, and liquid will be converted into vapors then. But when the atmospheric pressure, it is being pushing the vapor. So when the liquid acquires the boiling point, then the vapor pressure and the atmospheric pressure, they are equal. And when the liquid starts boiling, the temperature becomes constant. So, in the thermometer there is mercury capillary. This is mercury thread or capillary. So, when the temperature, so this is very important point. When the temperature in the thermometer becomes constant, it is the boiling point. So very simple. When the temperature becomes constant, it is the boiling point of the liquid. So this is there. I am showing this. See children, this is wire gauze. It is simple wire mesh, and it has a layer of asbestos. It is fireproof material. It is on only one side, and this is tripod stand. We keep this. This has to be kept up. What is the function of this asbestos layer? That asbestos, it is fireproof, and it prevents from excessive heating. It controls the temperature, and so this is there, and so we keep a stand is there like this, and so let's see this is the stand, and here we keep. So this is a very important point to note. And you might have seen the thermometer. Thermometers are that size, and so they are suspended, and so this is about the determination of boiling point of any liquid. Now see children, this is the setup for determination of boiling point, and so you can see this is the stand, this is thermometer, I will show you, and this is wire gauze, this is tripod stand, and this is the thermometer. Now see thermometer, this is thermometer, and this lower portion, the shiny surface, see it is shining like that of metal. It is metal, it is mercury, and it is called as bulb, but we do not touch the bulb. And see here, there are the calibrations. See, there are the calibrations. We can see the temperature, and see that the mercury thread. This is called as mercury thread. Mercury thread, and just now it is having the temperature. See carefully. It is showing the temperature of 30 degrees Celsius. Room temperature is 30. This is mercury thread. So this is one point about the thermometer. How to use the thermometer? Now see. The thermometer, it has been kept suspended here. It has been fixed on the stand, and the thermometer, it has to be kept in such a manner that it should never touch the vessel, neither the bottom nor the sides of the this, and so we can use this. And here I have taken the glass rod for stirring something, because this is called stirring. Stirring and means mixing, but we call stirring in scientific language. It is stirrer or glass rod. So we rotate like this. Now see carefully. The thermometer bulb is here, just in the center of the beaker. Why it is in the center of the beaker? Because if it is in the bottom portion, then it will have the, it will be, it can be damaged. It can be damaged, and so as a result, we have this like this. And so it is there now. Here it has been started hitting. It has started hitting, and so still the vapors are not coming. Vapors are not coming. Vapors will come. Experiments requires lot of patience, lot of time, lot of practice. This is the theme of experiment. Any experiment. So this is wire gauge. Why we use wire gauge? Because wire gauge act as regulator of heat. If we heat the beaker directly, then what will happen? Beaker may crack. This wire gauze, it has their and a scientist named Rutherford has said. See, this is very important point. See the very famous quotation of Rutherford. What is written? If your experiment needs statics, you ought to have done a better. It means you have to do better for a statics point of view. So this is Ernest Rutherford. This is the portrait, and born on 30th August 1971, died on 19th October 1937, and bombarded of atoms by alpha particles. So this is about the scattering experiment. So this just I was saying, and this is there to have the complete information. So you are experimenting, you are doing some experiments, so you must have the complete knowledge. So now children, after some time, you can see water will come out, vapors will come out. So I was talking to wire gauze. So wire gauze, it has a coating of fireproof material, and it is called as asbestos. Asbestos is a mineral. Asbestos is obtained from the mines as like clay, and is fireproof. And on the wire gauze, simple wire gauze, and there is a layer of asbestos. Asbestos prevents from the sudden heating, and so it is there. So I will show you something like that. Now see children, here the temperature in this thermometer, it is it is still 30. It is still 30. It is initial temperature. Here I have taken, but now see this. Here the temperature, it has been, increased to, around 70. Just you can see, it is increased to around 70. We can have this like this, and so see here, it is, see, it is increased to, 70. Here the 70 mark. Now just I am again going to put here quickly. Now you can see, the vapors are coming. No, it's not, a cold season, it's quite hot. So see, you can see the vapors are coming occasionally. Vapors are coming occasionally. You can see the vapors are visible. As it is hot, so vapors formed. So see the vapors are coming. Vapors are coming. See the vapors are coming, and this indicates that water is going to boil very soon. So now see the vapors are coming, and so it is going to have just, it was around 7 degrees Celsius temperature. So it is 30 was the initial temperature. It has increased to 70. Now just 100 it will increase, and so you can see it is around it is increased. You can see the vapors. See the water vapors are coming. Water vapors are coming out of the beaker. Water vapors are coming out of. You can see the vapors are visible. And when water starts boiling, the temperature becomes constant. When water starts boiling or any liquid starts boiling, there is no rise in temperature. So question is, where the temperature goes? We are heating continuously. So where does the temperature go? Actually children, the temperature is used in converting the liquid into the vapors. Liquid is converted into vapors, and as a result, the temperature heat is gone, heat is wasted. So this is there. So you can see the vapors now, they are more coming. You can see the bubbles have collected. Bubbles have collected, in between. So here I am using, see the vapors. Just I am trying to show you the vapors of the water. You can see there water vapors are coming, but in less amount. But as the temperature, it has increased to 80, and so slowly and slowly. Now see the bubbles. Bubbles are coming occasionally from the bottom. Bubbles are coming occasionally from the bottom of the beaker, and more vapors are coming. So you can see the vapors are coming, and so occasionally bubbles they are starting from this, and when the boiling point is reached, the temperature of the thermometer will become constant. So this indicates that 100 degrees Celsius is the boiling point of water. And so see, water, just it has started boiling, and so just I am using this screen to prevent the air to come out. So see here, just now see, just see children, water started boiling. You can see, but not boiling, not regular, and so we can have the temperature. We can have the temperature. See, water started boiling, children. See, you can see the bubbles from the vessel. It has started boiling. So this is the boiling. Now we'll show you the temperature. How, but still it is not 100. It is not constant temperature is required, and so now see, water started boiling, and the temperature, children, I will show you temperature. First is the boiling of the water. Then I will still the temperature, it is around 100. So just I will show you. Just it is just now it has started boiling. You can see. Just I am going quickly to show you. See this, children. See this 100 degrees Celsius. This point. So this is the temperature. This 100 degrees Celsius is the boiling point of water. And see again. You can see. Again, you can keep here. Again, for sake, you can see here. And see, this temperature here 100 degrees Celsius. So this is about the boiling. So this is for water. For other liquids, we use slightly different change in the style. So this is all.